Welcome to my walkthrough video for the Edexcel GCSE Maths Paper 1 Higher from November 2021. So for each question in this paper, I'm going to give a brief rundown of the involved topics and then go into my worked solution. It's important to realise, obviously, that my solution is not always going to be the only valid solution, and if you've used a different method and still got the correct answer, that's also fine. So question 1a is a simple multiplication. It asks us to find the value of 3.67 times 4.2. So obviously this is paper 1, so we're not allowed to use calculator. We have to just use a pen and paper. And I prefer to use the grid method for multiplication. So we're going to break each number down basically into its constituent parts that are easier to deal with, multiply them individually, and then add all of our results together. So obviously for the 3 we break it down into 3, 0.6 and 0.07. It's important obviously to remember the place value of each number, each individual part of the number. And then 4.2 we break down into 4 and 0.2. So 4 times 3 is 12, 4 times 0.6 is 2.4, 4 times 0.07, 0.28, and then 3 times 0.2 is 0.6, 0.6 times 0.2 is 0.12. Obviously, this can be a bit more, these sorts of multiplications can be a bit more difficult. If you need to, you can sort of think of them as, multiplying this number of tenths together and work from there. Then 0.2 times 0.07 is 0.014. So here we can see we've sort of kept, maintained the size of this number as well as just, doing the standard multiplication. We then add all these together. So 12 and 0.6 gets us 12.6. 2.4 and 0.12 gets us 2.52. And 0.28 plus 0.014 gives us 0.294. We can then add 12.6 to 12.52 to get 15.12. And 15.12 we'll add the last bit on the end, 0.294, to get us our answer of 15.414. Part B of question 1 is a simple division. We're asked to do 59.84 divided by 1.6. Now to do this sort of thing in a non-calculator setting, I like to use chunking, which is effectively where we subtract away chunks of they're generally multiples of whatever our divisor is, and from there we can see basically obviously how many lots of 1.6 we've got in 59.84, which obviously is a question that we're being asked. So we're going to start by subtracting 48, which we know is 30 times 1.6. So we're going to sort of write down our 30 here, which leaves us with 11.84. We can then take away 8, which we know is 5 times 1.6. So we're left with 3.84. We then take away 3.2, which is 2 times 1.6. And we're left with 0.64. Obviously, this is where a bit of our knowledge is going to come in. We can think, that 64 is 3 times 16. And so there's going to be some sort of simple relation between these two. We could see that 0.64 is 4 times 0.16, and so it's going to be 0.4 times 1.6. So we've got all of these chunks that we've taken out here, and we just add them together. So 59.84 divided by 1.6 is 30 plus 5 plus 2 plus 0.4, which gives us 37.4. Question 2 defines 3 sets for us. We have the everything set, the universal set, which is even numbers less than 19. We have set A, which is 6, 12, and 18. And we have set B, which is 2, 6, 14, and 18. And we're asked to sort all the numbers in the universal set into this Venn diagram. So we're obviously going to just iterate through all of the even numbers less than 19. And depending on, obviously, the membership of set A, set B, or neither, we're going to put them into the correct region. So first of all, we have 2, which we know is in just set B and not set A. So we put it in the exclusively B part of the Venn diagram. 4 is in neither set, and so we put it in the just the outside area basically. 6 is in both sets, so we put it in the intercept. 8 is in neither, so we put it in the outside. Same for 10, also goes in the outside. 12 is just in set A, so we put it in the exclusively A region. 14 is just in B, so we put it in the exclusively B section. 16 is in neither, so we put that in the outer area. And then 18, our last number in the universal set, is in both A and B, so we put that also in the intercept. So this should be what your Venn diagram looks like. Question 3 is basically a subtraction problem with mixed numbers, and we're asked to give our answer as a mixed number. So what we immediately don't like about this question is that they're using different denominators. So this is 4 and 1/5, and this is 2 and 2/3. And that's going to make the question harder than it needs to be. So the first thing we want to do is change from mixed numbers into improper fractions, because they're just easier to work with. So 4 plus 1/5 is equal to 20/5, which is the 4 part, plus 1/5, so it's 21/5. And then 2 and 2/3 is 6/3, that's the 2, plus 2/3, so that's 8/3. Now we want to change these fractions so they've got the same denominator, and obviously we can, because 3 times 5 is 15, we know we can make them both be over 15, and so we change that now. So we can use our trick of, multiplying by 1, which obviously doesn't change what the number is, you can just change how we write it. But in this case, we write 1 as 3 over 3. So 21 divided by 5 becomes 63, that's 21 times 3, divided by 15. And 8 over 3 multiplied by 5 over 5, again multiplying by 1, becomes 40 divided by 15. So now we can actually do the calculation. 63 over 15, take away 40 over 15, gives us 23 over 15. We know that 23 is a prime number, and so we can't simplify this fraction because we couldn't divide 23 by anything to, make it smaller, basically. So we have to just make this fraction now into a mixed number. So 23 over 15 can be rewritten as 15 over 15 plus 8 over 15. That 15 over 15 again is just another way of writing 1. So our final answer is 1 and 8/15. And obviously, you could also write it like this. You guys can just write 1, 8/15. That'd also be correct. Question 4 talks about percentage increases and decreases. So we're told that at the end of 2017, the value of Tamara's house was £220,000 and the value of Raheem's house was £160,000. We're then told that by the end of 2019, the value of Tamara's house had decreased by 20% and the value of Raheem's house has increased by 30%. And we're then asked to find out at the end of 2019 whose house has a greater value. So we need to calculate the prices of both houses at the end of 2019, and we're going to use, obviously, the percentages we're given. So Tamara's house is going to be worth £220,000. That's the value in 2017. Subtract 20% of £220,000. So we can say that obviously quite easily 10% of 220,000 is 22,000, and so 20% of it will just be twice as much, so 44,000. So Tamara's house value will be 220,000, subtract 44,000, which is £176,000. Raheem's house will be worth 160,000 plus 30% of 160,000. Again, we can quite simply find 10% of 160,000 is 16,000, and so 30% will be 3 times as much, that's 48,000. So the value will be 160,000 plus 48,000, which is £208,000. So we can see quite clearly that by the end of 2019, Raheem's house will have the greater value. Question 5 is a ratio question, and we're told that Rosie, Matilda and Ibrahim collect stickers, and the ratio, obviously with the number of stickers, Rosie to Matilda to Ibrahim is 4 to 7 to 15. And then we're told that Ibrahim has 24 more stickers than Matilda. And finally, we're asked how many more stickers does Ibrahim have than Rosie. So, because ratios are just describing the the quantitative relationship between objects, we can just take it straight to an algebra problem. So we can say R for Rosie equals 4x, M for Matilda equals 7x, and I for Ibrahim equals 15x. We know obviously we're told that Ibrahim has 24 more stickers than Matilda, so I equals M plus 24, or 15x equals 7x plus 24. If we then subtract 7x from both sides of this equation, which we can do, we end up with 8x equals 24. If we then divide both sides by 8, we get x equals 3. So Ibrahim equals 15x, Obviously from this we can see that's 45 stickers, and R for Rosie, 4x, which is equal to 12. So the number of stickers that Ibrahim has more than Rosie is 45 subtract 12, which is 33. Question 6 is looking into the volume of a prism. So we're shown this prism here where we can see the leading face is obviously a right angled triangle with a base length of 5 centimeters, and the length of the prism itself is 25 centimeters. We're also told that the prism has got a volume of 750 centimeters cubed, and so we're asked to work out the height of this prism. So we know that for any given prism, the volume of the prism is the area of this shape, the leading shape, multiplied by the length. And so in this case, it's going to be the area of this triangle multiplied by 25. So we know the area of a right angle triangle is half base times height, and that our base is 5 centimeters. So we can say that the area is 0.5 times 5 times h, or 2.5 h. And as we said before, we know to get the volume from area times length. So 2.5 h times 25, that's the length of the prism. And we know obviously this volume is going to be 750. So 750 equals 2.5 h times 25. And so we can rearrange this equation, divided by 2.5 and 25 to get h is equal to 750 divided by 2.5 times 25. If we then divide top and bottom by 25 to sort of try and resolve this fraction a bit, we know that 750 divided by 25 is 30, so we get h is 30 divided by 2.5. We could then simplify the fraction by multiplying top and bottom by 2, so we get 60 divided by 5, and obviously we know that 60 divided by 5 is 12, so the height of the prism is 12 centimeters. Question 7 looks into the surface area of different shapes. So we're given a cube with side length x centimeters and a sphere of radius 3 centimeters. And we're also told that the surface area of a sphere is 4 pi r squared. This is an equation that we're generally going to get given, but we don't know if we're going to get given this equation, so it's good to just memorize it anyway. We're told the surface area of the cube is equal to the surface area of the sphere. And we're trying to show that x is equal to the square root of k pi, where k is an integer, so a whole number. So, as I said, the most important statement here is that the surface area of the cube is equal to the surface area of the sphere. So we can write SA cube is equal to SA sphere. So we need to form equations for both of these things, obviously, where we can eventually get some expression for x. So the cube's got 6 faces, each of length x and width x, and so the area of each face will be x squared. So 6 of those gives us a surface area of 6x squared. Obviously, we're given the equation for the surface area of the sphere is 4 pi r squared. We know that r is 3 centimeters. So we have 6 squared equals 4 pi r squared, obviously substituting in our value of 3. So 6x squared equals 4 pi times 3 squared, which as we know is 9. So 6x squared is equal to 36 pi. Now we want to rearrange for x, which is what we're looking for. So we're going to divide both sides by 6. We obviously know 36 divided by 6 is 6. So x squared is 6 pi. And obviously then, to get to our value of x, we just square root both sides. So we get x is the square root of 6 pi. So obviously, in this case, our value of k is 6. Question 8 looks into a quadratic expression. So we're asked to solve x squared equals 5x plus 24. Now, if we want to solve a quadratic equation, it's normally best to rearrange it into this form. So ax squared plus bx plus c equals 0. So that's what we're going to do first. We're going to subtract 5x plus 24 from both sides. So we end up with x squared minus 5x minus 24 equals 0. Now there's 3 main methods we can use to solve quadratic equations. There is factorization, which is normally the easiest, but can't always be done. Completing the square, which can generally be done and is a bit harder. And then using the quadratic formula, which normally takes the longest, but that will work for every single equation, whereas sometimes the other 2 will be a bit harder to actually get going. But in this case, we can factorize it pretty easily. We're looking for, basically a and b here in this bracketed form, and we're looking to make it so that a times b gives us minus 24. Obviously, there's a minus here, so that's going to be ensured. And a plus b, in this case, obviously a minus b, gives us minus 5. So yeah, we need 2 numbers that add to minus 5 and multiply to minus 24. 3 and minus 8 are these two numbers. So we're going to get x plus 3 brackets, and then another set of brackets, x minus 8 equals 0. So this equation will be true if either of these sets of brackets are equal to 0. So either x plus 3 equals 0, and so by subtracting 3 from both sides, we have x equals minus 3, or x minus 8 equals 0, and so adding 8 to both sides, we get x equals 8. So the solutions, plural, to this equation are x equals 8 or x equals minus 3. The whole of question 9 is looking into our different indice laws, and part A asks us a very simple question to write down the value of 7 to the power of 0. Now, one of our very basic indice laws that we can prove, but we don't need to in this scenario, is that any number taken to the power of 0 is just 1. So 7 to the power of 0 is 1. Question 9b is a little bit more complicated. We're asked to find the value of 3 times 3 to the power of 6 times 3 to the power of minus 6. Now, when we multiply powers of the same base, so in this case the base being 3, we add up the powers. So if we do 3 times 3 to the power of 6 times 3 to the power of minus 6, that's going to give us 3 to the power of 1 plus 6 minus 6. Obviously, the plus 6 and the minus 6 cancel out, so we're just left with 3 to the power of 1, which we know, of course, is just 3. 9c looks a bit at negative powers, so we're asked to find the value of 2 to the power of minus 4. Now, the definition of a negative power such that if we have x to the power of negative y, then that's equal to 1 divided by x to the power of positive y. So in this case, we can obviously rewrite 2 to the power of minus 4 as 1 divided by 2 to the power of 4. And obviously we can iterate through, but you could also might just know this off the top of your head, that 2 to the power of 4 is 16, and so the value of this is 1 over 16. And finally, in part D of question 9, we're looking into fractional powers. So we're asked to find the value of 27 to the power of a third. So fractional powers give us the answer such that x to the power of y divided by z gives us the zth root of x to the y. This might be a bit of a confusing concept here. So for example, if z was 2, would be the square root, 3 would be the cube root, and so on and so forth. So in this case, we have obviously 27 to the power of 1 over 3. So that's the cube root from the 3 of 27 to the power of 1. Obviously, the power of 1 is redundant, so it's just the cube root of 27. And we know that 27 is 3 cubed, and so the final value of this is 3. Part A of question 10 is a compound area problem with a little bit of estimates put in there. So we're shown a shape made from 6 identical squares, and we're told that the total area of the shape is 5,406 centimeters squared. And we're asked to find an estimate for the length of one side of each square. So obviously when we hear the word estimate, we know that we can sort of mess around a little bit with the numbers that we're given to make the maths easier. And so in this case, we'll abbreviate 5,406 to 5,400 because we know that 6 times 9 is 54, and so we know that 6 times 900 is going to be 5,400. And so obviously we can say if we have a side length x of one of these squares, the area is going to be x squared, and so we have 6 squares, the area will be 6x squared. And so we can write the area of all squares, 6x squared, is equal to 5,400. We divide both sides by 6, we get x squared equals 900. And luckily, 900 is a square number, so we can quite easily just find x is 30. Now obviously, another way you could look at this is that because 5,406 is a multiple of 6 also, you divide that by 6 and you get 901, and you think to yourself, well, I can now abbreviate that 901, the value of x squared, to just be 900, and also get 30. Either of those ways are equally valid. And so part B of question 10 asks us whether our answer to part A was an underestimate or an overestimate. Now obviously there are multiple valid ways to do part A, and so it varies, but in this particular case, we rounded down the area value, and so any associated value is just going to involve, dividing like it did in square rooting. It's going to be smaller than it should be, and so our answer is an underestimate. And the way that obviously we've said that is that because we abbreviated the area to 5,400, which is smaller than the true value, every value we then obtain will be an underestimate. So question 11 is a bit of a combination of an algebra problem and also an area problem. So we're given two rectangles, A and B. Rectangle A has got side length 6 and 2w plus y. and rectangle B has got side lengths 3y plus 6 and 7w. We're told that all measurements are in centimeters, the area of both rectangles is the same, and we're asked to find an expression for y in terms of w. Obviously, we're told the areas are equal, but we don't know what the areas are yet, so it'd be useful to find these areas. So the area of A is 2w plus y times by 6, which is 12w plus 6y, and the area of B is 3y plus 6, all times 7w. So obviously, 3y times 7w is 21wy, and 6 times 7w is 42w. So we can write from the equivalent areas, we can say 12w plus 6y, that's the area of A, is equal to 21wy plus 42w, which is the area of B. So to make y the subject, we need to get all the y's on one side first. So we're going to subtract 21wy from both sides and also subtract 12w from both sides, which gives us 6y minus 21wy equals 30w. And we can see we've still got this w here we need to get rid of. So we're going to factorize the left-hand side into y brackets 6, that's this bit here, minus 21w, which would be this bit here, which obviously still is equal to 30w. And so to just end up with y on its own, on one side, we divide both sides of the equation by this bracket here, and we end up with y is equal to 30w divided by 6 minus 21w. Question 12 gives us a cumulative frequency table for the heights of 40 plants. And part A asks us to draw a cumulative frequency graph for this information. So because the interval of the heights starts at 0 for all of the intervals, we're going to start at 0, 0. That's obviously because the initial height is 0, and before we've gone through any of the height of the plants, we're going to have looked at 0 plants effectively. And then from there, we're going to plot the end of each interval, so 5, 10, 15, so on, with the cumulative frequency of the same row. And that's because obviously only once we've looked at the entire interval can we be sure that we've obviously looked at the height of every single plant in that cumulative frequency bit. So we're going to plot 5, 4, 10, 11, 15, 24, 20, 34, 25, 38, and 30, 40. And then we're going to link these points that we've just drawn with a line. Part B of question 12 then asks us to use this graph we've just drawn to find an estimate for the median height of the plants. So we have 40 plants, and we know that the median of an ordered data set is the middle of that. And so for 40 objects, obviously, that's sort of both object 20 and object 21. So we have to sort of use, in this continuous sense, plant 20.5. So we go across on the cumulative frequency from 20.5 to our graph, and we then go down to the corresponding height value, which is 13.75 centimeters, at least the way that I've drawn the graph. And if you've done this and got a slightly different answer, the correct answer range for this question, given in the mark scheme, is between 13 and 14 centimeters inclusive. So if you've got any value in that range by doing a similar method to this, then you would get full marks. Question 13 looks at changing recurring decimals into fractions. So Ted has tried to change 0.43 recurring into a fraction, and he's done this. He's said x is 0.43 recurring, 10x must be 4.34 recurring, and then so if we do 10x minus x, we get 4.34 recurring minus 0.43 recurring. And we're asked to evaluate Ted's method so far. So when we're trying to turn a recurring decimal into a fraction, what we want to do is use some sort of power of 10 multiplication to align the sets of recurring decimals, so we can eliminate them by subtraction. So he's tried to use the wrong power of 10 here. If we want to do this properly, we need to do 100x, so that it moves everything along to the left by 2 spaces, and so the 4 and the 3 in both cases are aligned again. So we end up with 100x equals 43.43 recurring, where this square bracket notation means recurring. If we then do 100x minus x, we get 43.43 minus 0.43. Obviously, we can see it's just going to cancel out the 43, so we're left with 99x, obviously 100 minus 1, is equal to 43, and so x is 43 divided by 99. So our evaluation should just say that Ted needs to use 100x rather than 10x in order to align the recurring decimals and then eliminate them. Question 14 is a compound area problem. So we're given a shape with all measurements in centimeters. So we've got this, the width of this particular bit is x plus 1, this length is 4, the height of the whole shape is x plus 11, and the width of the whole shape is 2x plus 6. And we're told that the area of the shape can be written as capital A centimeters squared. And so we're asked to show that A is equal to 2x squared plus 24x plus 46. So when you have a compound area problem, you want to break the shape into more simple shapes that you can find the area of quite easily. So in this case, I'm going to draw this line across here. And obviously, we can see this like this length here must be x plus 7, because obviously x plus 7 plus 4 would give us this x plus 11 height. So the area of the smaller top rectangle is 4 times x plus 1, which is 4x plus 4. And the area of the bigger bottom rectangle is x plus 7 times by 2x plus 6, which we can expand out to find is 2x squared plus 20x plus 42. So the total area of the whole shape is going to be 2x squared plus 24x plus 46, which obviously, as we know, is equal to A, which is what we're trying to prove. Question 15 gives us two fractions, 4x plus 3 divided by 2x and 3/5, and we're asked to rewrite those as one single fraction, ax plus b over cx, where a, b, and c are integers. So if we have two fractions like this that we're trying to add, subtract, whatever, with different denominators, we want to make them both have the same denominator to make the maths easier. And so you can see that a sort of simple common denominator to use here would be 10x. It's a simple multiple of both. And so we'll change that over now. So if we start with 4x plus 3 divided by 2x, we simply multiply the top and bottom by 5, which we can do, and that doesn't change the value of the fraction. So we end up with 5 brackets 4x plus 3 divided by 10x. And then for 3/5, we multiply the top and bottom both by 2x. So we get 3 times 2x divided by 10x. And so if we add those together, we get 5 brackets 4x plus 3 brackets 2x, all divided by 10x. 5 times 4x is 20x, 5 times 3 is 15, and 3 times 2x is 6x. So we just simplify this bracket here, and we get 26x plus 15, all divided by 10x. So for this combined fraction, A is equal to 26, B is equal to 15, and C is equal to 10. So question number 16 is about probability, and we're told that there are only 3 red counters and 5 yellow counters in a bag, and that Jude takes at random 3 counters from the bag. And we're asked to work out the probability that he takes exactly 1 red counter. So we have to look at the different ways that he can take 1 red counter. So he can take red, then yellow, then yellow, yellow, then red, then yellow, or yellow, then yellow, then red. So the probability of taking red, yellow, yellow would be 3 out of 8, that's the 3 red counters out of 5 total, then 5 out of 7, that's 5 yellow out of the 7 that are left, times 4 over 6, that's the 4 remaining yellow counters out of the 6 total. So obviously, if we multiply fractions together, we multiply the numerators together and the denominators together. So in this case, 3 times 5 times 4 divided by 8 times 7 times 6. So 60 divided by 56, 8 times 7 times 6, which gives us 60 over 336. For yellow, red, yellow, 5 yellow out of 8, so 5/8, 3 red out of 7, so 3 over 7, and then 4 yellow out of 6, 4 over 6. So 5 times 3 times 4 divided by 8 times 7 times 6. This is just the same as before, but written in a different way. So 60 over 336. And then yellow, yellow, red. Might be about to spot the pattern now. 5 over 8. Then 4 over 7, obviously. Still is yellow. And then finally for the red, 3 over 6. So 5 times 4 times 3 over 8 times 7 times 6. Again, this is the same multiplication because multiplication doesn't matter what order it's been done in. So 60 over 336 once again. And obviously any of these possibilities will give us that condition that he only takes 1 red counter, and so we add them together to find the overall probability. So probability of taking exactly 1 red is 60 over 336 plus 60 over 336 plus 60 over 336, which is 180 over 336. Now, we could simplify this from here, but we don't need to because that's a very valid answer to this question. It didn't say anywhere, express the probability as the most simple version of the fraction. Question 17 combines both inequalities and graphing linear equations. So we're asked to show by shading on this graph the region that satisfies all of these inequalities. 2y plus 4 is less than x is less than 3, and y is less than 6 minus 3x. So the important thing to recognize here is that inequalities are quite weird graphically. The way that we actually sort of think of them is by using the corresponding equation and then just bringing in that unequal property at the end. So we're actually going to plot 2y plus 4 equals x, x equals 3, and y equals 6 minus 3x, and then sort of bring back that idea later on. So we'll rewrite the first inequality in standard linear equation form. So that's we subtract 4 from both sides to get 2y is smaller than x minus 4, and then divide both sides by 2 to get y is smaller than x, 0.5x minus 2. So then we're going to just imagine this is a linear equation. So we're going to plot y equals 0.5x minus 2. So it's y-intercepts at minus 2, and its gradient is 0.5, so we draw that on. And then remember we've got this y is less than property. So we're looking at everything below this line, and these obviously the red arrows indicate this. Then we've got x is smaller than 3, and so again we're going to do x equals 3, which is this vertical line here through, obviously along the line of x equals 3. And we're going to think obviously we want x to always be smaller than, so we're pointing left as these green arrows show. Finally we've got y is smaller than 6 minus 3x, so we're going to plot again a line that's got y-intercept of 6 and a gradient of negative 3. Remember then obviously the less than idea, so we're looking below a line, so these arrows obviously point to that. And then we're just looking to the region that all these arrows are pointing to. So obviously it can't be anywhere here because this wouldn't satisfy red. It can't be anywhere here because this wouldn't satisfy the blue, and so on and so forth. But this area here, the grey, satisfies all these inequalities. And then obviously one thing I've actually forgotten to do is label this region R. Question 18 looks both into trigonometry and also the area of quadrilaterals. So we're given a trapezium ABCD, and we're told that the side length BC is 6 centimeters and that the angle BCD is 30 degrees. We're also told the area of the trapezium is 66 centimeters squared, and that the length of AB to the length of CD as a ratio is 2 to 3. So we have to find the length of AB. So remember, obviously, the area of a trapezium is the height times by a plus b divided by 2, where a and b are these variable but parallel sides. So first of all, we need to work out the height. So we're going to form a triangle here, going vertically down from b, and that opposite length is going to be our height, and obviously our hypotenuse is 6 that we already know. Obviously that's around the angle 30. So looking for O and H, so we're going to use SO from SOHCAHTOA, so sine 30 is equal to O divided by 6. And we can rearrange that, multiply both sides by 6 to say that O, the height, is equal to 6 sine 30. Now, this is obviously a non-calculator paper, but sine 30 is one of the exact values that you do have to know, and sine 30 is equal to 0.5. So obviously 6 times 0.5, O, the height, is 3 centimeters. So we know now that 66 equals 3 as the height, times by a plus b divided by 2. If we divide both sides by 3, we get that a plus b over 2 is equal to 22. Obviously, again, we multiply both sides by 2 and get a plus b is 44. We know the two sides are in the ratio 2 to 3, so because AB is the shorter side with the 2 units, it must make up 2/5 of this total, a plus b. And so AB is 2/5 of 44, which is 17.6 centimeters. Question 19 is mostly about surds, but has a little bit of fractions involved. So we've given this fraction 8 plus square root 12 over 5 plus square root 3, and we're asked to rewrite it in the form a plus square root 3 over b, where a and b are integers. So a general principle is that we don't like complicated things in denominators. We don't like, powers, we don't like surds, we want them to be nice, simple expressions. And obviously this is hinted to by the fact that we just want an integer eventually for this question. So to get rid of a surd in a denominator, we use something basically similar to a difference of two squares. So if we have x plus square root y, we're going to multiply by x minus square root y. And if we sort of propagate through that multiplication, we can see we're going to end up getting rid of any square roots involved. So when we do this, obviously to change this denominator over, we need to multiply the top and bottom by 5 minus square root 3. So we're going to end up with 8 plus square root 12 in brackets times 5 minus square root 3 in brackets, all over 5 plus square root 3, 5 minus square root 3. So if we start to expand this out now, 8 times 5 gives us 40. The 5 times square root 12 gives us 5 square root 12. And the 8 times minus square root 3 gives us minus 8 square root 3. And finally, obviously, square root 12 times minus square root 3 gives us square root 36. And then we divide by, obviously again, going to expand these brackets out, 25 from 5 times 5, 5 square root 3 from here, and then minus 5 square root 3 from here. So they're going to cancel out, obviously, as we wanted them to. And then minus 3 from plus square root 3 times minus square root 3. Simplifying these brackets, we're going to get 40 plus 5 square root 4 square root 3. That's just the rewriting of this square root 12, minus 8 square root 3, minus 6, obviously, because the square root of 36 is 6. And we're dividing that by 22. Obviously, these cancel out, so it's just 25 minus 3 is 22. So we're going to continue to simplify. We can do 40 minus 6 to get 34, plus 10 square root 3 minus 8 square root 3. And we got the 10 square root 3 from, obviously, square root 4 being 2. Again, dividing all by 22. Finally, we simplify once again to 34 plus 2 square root 3 divided by 22. Obviously, that's just 10 minus 8 square root 3. Obviously, we don't want a coefficient of square root 3. We want it to just be on its own. So we're going to divide top and bottom by 2, and obviously that remains the same value. So we're going to get 17, 34 divided by 2, square root 3 divided by 11. So in this case, A is 17 and B is 11. Question 20 is about both circles and simultaneous equations, and even brings in a little bit of graphically estimating solutions. So the diagram shows a graph of x squared plus y squared is 30.25, which you should know is the equation of a circle, which is what we're given. And we're asked to use this graph to find estimates for the solutions of the simultaneous equations x squared plus y squared equals 30.25 and y minus 2x equals 1. So what an equation actually says is, the bit on the left is equal to the bit on the right. So when it involves x's and y's in a graphical sense, that's saying, okay, look at any given point, give me the x coordinate, the y coordinate, put them into this formula, and then is that actually equal to this? And the sort of solution, the graph that we get, is all of the points where that's true. So the circle obviously is where x squared plus y squared is equal to 30.25. And similarly, when we plot y minus 2x equals 1, it's all the points where the y coordinate minus 2 times the x coordinate is equal to 1. And so when we say simultaneous, we mean at the same time, both are true at the same time. So how would we know that both of these equations are true at the same time? Well, it's if a given point is on both the circle and the line that we draw. So I'm going to plot that line on the graph, and wherever we have the circle crossing the line, we know that in that case, both the equations are true, and therefore they are the solutions. So we can rewrite this linear equation in our normal form by adding 2x to both sides, and we get y equals 2x plus 1. So obviously we're just looking for a line with y-intercept 1 and gradient 2. And then we're going to look at these intercept points here, and we're going to look obviously pretty roughly because we've just plotted a line. So the solutions I've got are x equals 2.1 and y equals 5.1. That's up here. And x equals minus 2.9, y equals minus 4.7, which is down here. These are the exact answers that are given in the mark scheme, but you're allowed 0.1 above or below in both. So if you've got something in that sort of range, 0.1 up or down, that'll be also correct. Question 21 looks at composite functions. So we're told that the functions f and g are such that f of x equals 3x squared plus 1 for x greater than 0, and g of x is 4 divided by x squared for x greater than 0. And part A asks us to work out g of f of 1. So when we say g of f of 1, we work from the inside out. So we're going to apply f to 1 first, and then apply g to the result of that. So gf of 1 effectively means g of f of 1. So f of 1, of course, is 3 times 1 squared plus 1. That's obviously going to be 4 because 1 squared is 1. And then we want to do g of f of 1, so g of 4. So we're going to do 4 divided by 4 squared, which is obviously 4 over 16, which is equal to a quarter. And then part B of question 21 tells us that the new function h is such that h is the inverse function, that's this, what this minus 1 notates, of fg. And we're asked to find h of x. So the inverse function basically asks, what do I need to input to get this certain output that I want? So basically just going backwards. So with part A, we've got to look at the statements right to left. So fg means f of g of x. So firstly, we'll evaluate what f of g of x actually is. So if we're doing f of that, then it's going to be obviously 3 something squared, so 3g of x squared plus 1. We know obviously that g of x is 4 over x squared, so it's 3 brackets 4 over x squared all squared plus 1. If we square this fraction, we obviously square the top and the bottom, so 16 divided by x to the power of 4 plus 1. Obviously we're going to multiply by 3 now, so 48 over x to the 4 plus 1. So to find the inverse of a function like this, what we do is we basically rewrite the x's as y's and then solve for y. So x equals 48 divided by y to the 4 plus 1. So we're going to subtract 1 from both sides first. So x minus 1 equals 48 divided by y to the 4. We're then going to divide both sides by 48. So x minus 1 over 48 equals 1 over y to the 4. And then we're going to flip both fractions, which we can do. They're still going to be equal if we take the reciprocal of both sides. So y to the 4 equals 48 divided by x to the 1. So as you can see, we just flipped numerator and denominator. Finally, we take the fourth root of both sides. So y is the fourth root of 48 divided by x plus 1. So the final question of the whole paper, question number 22, is looking at turning points of quadratic equations. So we're asked to find the coordinates of the turning point on the curve with the equation y equals 9 plus 18x minus 3x squared. So really important piece of knowledge about the turning point is that it's always directly in the middle of the two roots of the equation. So if we can find the roots of the equation, we can simply find the x coordinate of a turning point. Then by substituting that x coordinate back into our equation, we can find the corresponding y value. So this equation, to find its roots, will be quite difficult using factorizing or completing the square. So we're going to just simply use the quadratic formula. So obviously for this, a equals minus 3, b equals 18, and c equals 9. Obviously just a being the x squared coefficient, b being the x coefficient, and c being the lone number on the end. We know the quadratic formula is x minus b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to substitute in now. Minus b, so minus 18, b squared, so 18 squared, minus 4 times a, minus 3, times c, 9, divided by 2 times a, which is minus 3 again. We're going to simplify this now, so 2 times minus 3 is minus 6. We know 18 squared is 324, so you can work that out, pen and paper, or just memorize that number. And then 4 times minus 3 would give us minus 12, times by 9 gives us positive 108 because there's another minus sign here, all divided by minus 6 still. So now we're left with minus 18 plus or minus the square root of 432 divided by minus 6. Now, we could waste a ton of time now trying to evaluate square root 432 on minus 6, but that's just a waste of time, frankly. What we need to realize is that if we take the two numbers, so minus 18 plus square root 432 on minus 6, and minus 18 minus square root 432 on minus 6, the middle of those is just going to be ignoring the plus or minus, right? It's just going to be minus 18 on minus 6, therefore 3. So the x coordinate of the turning point is going to be 3. And to find the y coordinate, we just substitute 3 back into this equation. So 9 plus 18 times x, so 18 times 3, minus 3 times x squared, so 3 squared. 18 times 3 is 54. 3 times 3 squared, obviously 27, so minus 27. We know that 54 is 27 times 2, so we end up with just 9 plus 27, which is 36. So the coordinates of a turning point are 3, 36.